Hello, this is Ethan. This is my Project 2 screencast recording. And here's my .h file, which includes the memory manager class, which contains all the relevant functionality, as well as private variables. And just going over very briefly here, we used a vector of block structures in order to do memory management. Each block structure contains a size and offset and a Boolean free that indicates if it's free or not. And yeah. Also in compliance, we also have the best fit and worst fit algorithms outside of the general class. And yeah, moving on. Okay, so yeah, we start off with best fit. Best fit returns the offset of holes that has the most optimal. So the least space required to that's needed, and it returns either that value or -1. Worst fit does the opposite. It returns the largest available size for whatever your request is, and it either returns that value or returns -1. We have the default constructor and the destructor here, which obviously initialize variables or use calls shutdown to close them. We have initialize here, which utilizes mmap, extra credit here in order to do everything, and it either is unsuccessful, which returns the null pointer, or is successful, in which case we clear out the data in the free list, we push it back to the entire block, and then we set all of it to 0. Shutdown uses munmap to deallocate everything, and it deallocates other variables as well, just to make sure that there's no memory leaks and to ensure that everything is good when we are done. Allocate here uses a basically sorry, allocates memories in the allocator function. If there's no memory or it's invalid, we return the null pointer, which is here. Um, Important thing here is that for allocator, if the block size is perfect, that's awesome. If the block size is too big, we split it into what we need, size needed, as well as the size remaining. Size needed becomes utilized, and the size remaining is created as a new block. And yeah, moving on, we have get list here, which returns an array of information in little endian format about the holes. In this case, we use a lambda function here, which is super important. I found this on Stack Overflow, or it was referenced. And yeah, this get list basically just returns an array of information. Moving on, we have free, which is deallocating. As far as the project report expectation goes, free deallocates memory by looking for the block to be freed. And once it does, it checks whether or not the block before or the block after it is also free. And if either are, then they are merged properly, and that's to prevent fragmentation. And that is it. Get bitmap returns a bit stream of bits in terms of an array. Um, yeah, I mean, also in Little Endian, it's wordwise. It divides memory into words, sets bits within the bit stream to either 1 or 0. And yeah, moving on, we also have the dump memory map. Dump memory map uses standard POSIX calls to create a whole list and write to a file name as text. Um, and yeah, here at POSIX calls, we use right here, open file name ordwr, blah, 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 blah. And yeah, so it basically goes through and it sees if everything is either used or not used, and it'll write that accordingly. It's here's the write function for that, and then it's closed, and then we return. If it's unsuccessful, we return -1. We also have the get word size getter that returns word size, the get memory start getter, which returns pool, and get memory limit, which returns memory limit. We also have the set allocator, which chooses whether or not we use best fit or worst fit at runtime. Here we are. In the interest of time, we're going to use the build.sh to get valgrind, and as you can see here, that's the valgrind leak check full command. Oh shit, sorry. Slash build.sh. Waiting for it to run, and I'm running low on time, so I'm just going to run this very quickly, hopefully as fast as I can at this point. Um, yeah, so everything's done. As you can see, the total heap usage, all heaps were freed, no leaks. We also have 0 errors from 0 contexts. And here we're also going to run command line test. Just to show everything, we had a 38 out of 38 score. And yeah, that is basically everything. Thank you.